Well, hi, good morning. Thanks so much for joining me here. I've been working on this 1567 American-built radio here in Canada. Wait a minute. Whoa, everybody, slam on the brakes for a second. This radio says 1567 on the back, made in Michigan. This is the schematic that goes with it. This would be the, let's call it the American schematic, 1567. Well, thank you, Keith. One of you viewers, Keith, if this is you, you've really sent me into a terrible tailspin. Keith has sent me this schematic for the Sparton model 147. It's virtually identical to this one. Keith's comment is he thinks this is the Canadian version. Even though the radio says 1567, this seems to be a more accurate schematic. So I'm not going to say too much about it until I study it more, but I will say this. The area that I have been working on right in here is shown completely differently, I think. Because, then let me check this right now. Let's do this right now before I pull what's left of my hair out on this. So we know this IF coil in here was changed by one of the previous repair guys. That coil, I'm checking now. 1, 2. So I thought there were 4 wires coming out of it. Let's just get a little more light on it here. 1, 2, 3, 4 wires. I'm just being absolutely sure. 4 wires coming out of this coil. Like this one. 4 wires. 4 wires. Is it really 4 wires? 1, 2, 3. Looks like 3 wires in here. 1, 2. That's odd. That's kind of odd too. Okay, so I don't want to. Let's not expand the oddness, John. Stick with this one. 4 wires here on the new schematic, which may be more correct. That coil is showing center tapped. Maybe 5 wires coming out of that hole. So what this means, if this radio is actually built like this schematic, and there's reason to think it is, this could have been built in the United States for the Canadian market. It could have been done that way. Could be something special about it. Sometimes the grounding requirements, for the power companies is a little different in different countries. Maybe this is the Canadian version. If that's the case, then out came a 5-wire center tapped secondary transformer and was replaced with a non-center tapped 4-wire, more typical transformer. Oh, okay. In the schematic I've been following, you see it is a 4-wire on here. 1, 2, 3, 4. Whew, thank God. It's 4 wires here. So the network that appears here on this schematic, I'm going to go away and study this really carefully, appears here, but it looks different at a glance. So I'm going to compare those two things very carefully, and then chart my course forward from here. Oh my gosh, Captain, we're not where we thought we were. Okay, it's a bit of a tsunami of information here. So to compare these two radios a little bit tricky. I spent some time looking at them. I think I'm just going to give kind of an overview of the difference between these two schematics, and they are different. So this is the new schematic I just received. Thank you, Keith, for this. Here's the transformer that's been replaced in this radio. Notice it's center tapped. The 5 wires coming out of this coil. Not center tapped. And what's in the radio? Not center tapped. Is there a chance that what happened to this radio is something went wrong with this coil? A repair guy decided to replace it. Didn't have a center tapped one. He just had this kind, just a regular transformer. Grabbed it from a radio, stuck it in, then realized that all this network of capacitors and resistors is all around this center tap. which is no longer there, because now it looks more like this. So he went about doing things as best he could off the top of his head, basically. Ended up connecting the magic eye connection up here, way up here, and he ended up, instead of over here where it should be, and he ended up taking, like dumping all this. Well, it would have been gone, or it would never have been there. In fact, what would have been there would have been all this. But not having the center tap, he may have thought, you know, all this network's just not going to work out properly anymore. Far be it from me to explain why all these capacitors are here. I mean, in detail. I mean, generally speaking, it's all about getting rid of our RF and altering the audio response so it sounds nice, something like that going on. Separating out the DC for use on the ADC. I mean, that's what's going on here. But in detail, all these particular capacitors, yikes, they do not match at all with this down here. Also, for sure, on the other schematic, this takeoff on the back of the radio for phono, it doesn't exist at all on here. There is no phono input. So in that case, it matches. I looked at the rest of the circuitry. It's all pretty much identical, except right in this area because of this, I would say. Now there is something more interesting here in that this schematic, you can get down to the speaker here, shows the field coil, and if you follow the two wires up, you can see that they're actually associated with the power supply of the receiver. This is the amplifier. It's a little tricky to spot on this schematic. This dotted line here is marking out a different chassis, the amplifier chassis, which isn't on my bench. So the wires from the speaker field coil pass through the amplifier because they come in on the speaker cable, just pass through into the receiver where they take up a position on this on the high voltage transformer secondary center tap. So it's just a filter. It's just filtering this power supply, and the field coil can only be accessed by passing wires through the amplifier out to the speaker. Looks fairly simple, but when you look at the other schematic, simple goes out the window. On this one, I'm going to just wing this here. Let's just see if I can match all that up. So on this one, the speaker's showing way up here. You can see the field coil. If you try following that pair of wires there, it just kind of disappears into the radio going through resistors. It doesn't look the same. And I could never fathom where this was actually connected to field coil. Now another difference is, on this radio, they're showing the humbucking coil. There it is there. It says bucking coil. It's a component, or it's in series with the field coil, or sorry, voice coil, and the output of the output transformer. And if we look at the other schematic, there's no humbucking coil shown here. Now either it's there and they just didn't bother showing it, or it's not there anymore. But this is different. I don't think it's a big deal. It's just another difference. Like I say, the rest of this kind of matched up, but they're drawn differently. You know, they've been drafted differently, so it's a little hard to sit and compare the two in detail. I'll only do that where I get driven to it. So what am I going to do now about this completely different arrangement from what was in this version of the radio and pretty much what I put in here? I think my best move is to leave well enough alone. I've managed to pick this circuit, which is hooked up to a non-center tapped transformer, so maybe this is a more appropriate circuit anyway. I don't know. I think we're going to carry on. The next stage is to align this radio, which I'm going to talk about in a moment, and we're going to find out what it really sounds like pretty soon. Pretty soon, he says. Thought that a while ago. Some other differences now. Not really differences. You know what? We're going to look at this right on the computer screen. I won't use a camera here. Okay, so we're going to do a quick read through of the alignment instructions in case there's something tricky in here. You never know. Before commencing alignment, make sure dial is set so selector plates with the selector plates in flush. Selector plates, I guess we're talking about the capacitor. Pointer points to the last division on the dial. Of course, I don't have the dial yet, so some of the alignment activities I really can't do. I can't do the oscillator alignment just yet. But this first time through, the alignment is just to get it close. I'm not trying to be precise first time through. So here's how to do the intermediate frequency amplifier. I've done this. I did not follow this procedure precisely, but I think everything's okay, except look at this. This caught my attention. Caution! Once one set of IF trimmers has been adjusted, do not go back and readjust them after aligning the following set. After aligning the following set. That is, do not readjust C63 and 62. No, 63 after 62 and 61 after 60. Why'd they write it like that? That is, do not adjust C63 or C61 after C62. There's something wrong in that line. But I see the point here. They're saying, look at this. The output meter may show an increase by doing this, but actually the resonance circuits are thrown out of alignment. What? What are they telling me here? Now, I've been doing alignments forever, and I often pop back and forth between the different IF cans. Number 1 and number 2. Isn't there 3? Isn't there 3? 1, 2, 3? Where's 3? Look what they've done here. 61, 62, 63. Okay, so they haven't numbered each individual screw. They've just numbered the can. 61, 62, 63. Here they talk about 61, 62, 63. Yeah, okay, so that's a numbering convention. They're not following what most would do. So that covers all 3. Okay, so maybe this makes sense then. Do not touch 3 after doing 2, and do not touch 2 after doing 1. That's really what that should say, shouldn't it? Shouldn't it say that? Just 63 after 62, 61 after 62. What order are they doing them in? In just trimmers, 63, 62, 61. Okay, so I think this is just a typo in here. The part that's really got me on this, I'm really dwelling on, is this part. The output meter may show an increase by doing this, but actually the resonance circuits are thrown out of alignment. Like, is that some general truth that I've never realized? Oh my gosh. Well, I don't know what to say about that. Maybe it's pertinent to this particular radio for some reason. Wow. Okay. Add it to my list of things to ponder. Now let's go on with the rest of it here. Oscillator trimmer, oscillator patter. So I won't be doing these oscillators just yet. Like, I don't have the dial on the front. RF trimmers. This is what I want to make sure they're doing something and within reasonable range. So this 1500. Okay, that's no problem. Band number 2. 6000. Make sure the band switch turned to the red position, so I'll have to be careful about getting this correct. One thing about doing alignments is as you're working your way along and you're getting the radio more and more aligned, if you accidentally turn the wrong thing, you can undo a lot of the work you just did. So mistakes cause you to do a lot of rework here. Oscillator pattern. On the red scale. Yeah, so again, oscillators I can't really do properly. RF trimmers, I can do that. Number 3. Nothing here surprising. I know there's something surprising coming though. 1500, everything looks fine. Long wave X band. Oscillator RF trimmer. 350 kc, maximum caution. With the oscillator set at 15,000 hertz, two signals can be heard in the receiver, one at 15,000 and the other at 14,088. So what they're doing here is they're warning you that there's a problem with image rejection in the radio, and the image from a signal may be so strong that you can get confused and tune the radio up on the wrong signal. Do not mistake the latter signal for the former. In aligning the receiver at 1500, the signal of higher frequency is the correct one, and the set should be adjusted to it. Okay, so we'll have to be careful about this. Look at this last one. Do not bend selector plates. Okay, so the selector is variable capacitor. Do not bend selector plates, as this destroys selector alignment. So a lot of radios, I got an example. Is there anything more? That's it. Okay, that's the read through. Let's take a look at something else here. I think I have a radio chassis right here. Okay, bending the plates. Something I've never attempted. On these capacitors, can you see, especially on this set of plates, the outside plate is split. There's a split there and a split there, and likewise on the other side. The outside plates are split. Can you kind of see it there? Hey, is that a tube I need? 6SN7. Oh, that's from earlier tube experiments from quite a while ago. So one of the ways you can align a radio, and that's to correct problems with the pointer pointing okay at one end of the band, out in the middle, but back okay again at the other end of the band. So you can compensate for that kind of thing by bending these plates very selectively. Now, I'm not knowledgeable on how to do it. I often see radios where it's done. You can see it's been done on these. These are pulled out a little bit. So that affects the I don't want to say linearity, but I guess like a linearity of the pointer, or whatever it is that's happening on your radio. And I think this is really something that would be done, of course, in the factory, under circumstances where doing it is enabled. In other words, some kind of test jig or something. To do this myself, I've never done it. I've never bent these plates out. Once in a while, by the way, if people reach in and grab their radio to do something with it, and when they're done, one of these outside plates has been kinked over, pushed over, and shorts out. So it's good to look at these plates and see what's happening. Hey, what's happening in this radio? So I doubt very much the plates in this radio would be split. Let's see if we can spin it around here, see if we can get a look at it. So plates in question are down here, and sure enough, they have splits in them. Can you kind of see it there? Let's see if these things have been manipulated. I'm looking at the outside plate here, and they all look perfectly straight. So no attempt has been made to align this radio by bending these plates at all. That's what I would say, and I'm going to leave it like that. Incidentally, I could show this on my other one too. Another linearity factor that shows up on these. Yeah, I don't think it doesn't really show up here. I showed you that for nothing. Sometimes the plates are not perfectly semicircular. They may be a lot less plate at one end. And then as you rotate the dial and you rotate it linearly or steadily, the plate interaction actually is not linear because of the shaping of the plates. And it's a very complicated thing. I'm sure a lot of experimentation went into getting those variable capacitors figured out so they work so they work as linearly as possible. But still, when you look at the dial of a radio, you can see that the numbers often are not arranged linearly. They're crowded in at one end. Some radios, they can be crowded in the middle a little bit and spread at the ends. That's the last radio designer's chance to compensate for his whacked out radio that doesn't tune linearly. It's just compensate with the way the dial is numbered. Okay. Wow. So I'm pretty sure I should perform the alignment process here, and after that assess the radio and try and make some big decisions. like what? I don't know. Okay, I'm going to set everything up so we can do this alignment process here. Oh my gosh. Okay, so I think I'm just about ready to start, but I don't have the radio switched on yet or anything like that. Just going to explain what I'm going to do here. So it's really kind of simple. I'm going to put in a controlled signal out of this signal generator right into the antenna. And then the output volume at the speaker is going to be measured on this meter here. Don't pay any attention to this. This is just my personal "you're too loud" meter when I'm talking. So we just ignore that meter there. This is the one to watch. The frequency we're working at is shown on here. Right now it's 882 kilohertz, somewhere in the middle of the AM band. Let's take a closer look at the signal generator that I'm using. So this is quite a nice military instrument. So the first thing we're going to do, I'm going to explain some of the controls, and then I'm going to calibrate this for a controlled output. But it won't guarantee that's what the radio is really seeing. But let's go through the process. So starting here, this controls the output by a factor of 10. You can see it's called a multiplier. So if I snap this up from 10 to 100, I get 10 times as much power coming out here. 10 times as much power may not be the right word. 10 times as much signal, I'll leave it at that. This is the calibration. This is the calibration control. So we're going to set the carrier to 10 microvolts. Okay, microvolts control fully clockwise. That'd be this guy. So we're going to do that process in a second. So this guy here, I have to leave it in this position to energize this. So my counter is counting up above. That decalibrates the output of this unit. I seldom use this as a calibrated device because it's really quite challenging to really do this precisely. So you can see though that depending upon, so this over here is the selector for what band this is operating on. Right now it's on the 300 to 950 kilocycle. That's kind of obvious. You can read the actual frequency in these windows. It's really quite accurate, but not nearly as precise, of course, as my counter. Accurate or precise. So that's how you change the frequency. Easy enough. So this control controls what it is, what kind of, let's call it, program material is being sent on the carrier. So this thing produces a carrier, and then it can modulate the carrier with this control. It can take 1000 hertz, 400 hertz if you like. I can feed something in external, so I could use this as a transmitter if I really wanted to. And then these settings here, let's just get busy on this guy right now. So I'm going to calibrate this meter, or this generator. If I get this wrong, it really won't matter anyway. Okay, so I got to do that. Got to do. It's watching now. That's fine. Okay, so we'll set this now to 10. Dirty there. There we go. So conceivably there is now 10 microvolts on here based on the setting of this. Put this to X1, 1 times 10. 10 microvolts here. I could have this wrong by a factor of 10. In fact, I have to get the manual to be absolutely sure, but I think it's quite simple. 1 times 10. 10 microvolts, a very low signal. 100 microvolts will be a signal probably this radio should be able to receive it. It should certainly be able to receive that. We'll probably start here though. Give it a fairly strong signal. Okay, I flip this back. You'll see the calibration has indicates something else now. It's indicating modulation. Modulation is the percentage of the carrier that's being modulated. 30% is the usual place you set that. So that's on 30%. So that's now calibrated, ready to go. Here, there would be 100 times 10. So that'd be 1,000 microvolts here. At the other end of this wire, not necessarily exactly that, but somewhere in the range. That's kind of what's going on with the signal generator over here. I think I covered pretty much everything. Probably got a fair bit wrong, but that's okay. Now, because you can be a little wrong, you know. You don't have to be perfectly right all the time in life. You can be a little wrong here and there. Just don't be wrong about the important things, that's all. So let's turn this guy on now. So I'm going to have the audio available for the video, but we won't listen to it once I've decided the radio is working good. We won't listen to it. We'll just watch this meter. So let's get that happening. So I have the signal generator feeding into the antenna of the radio. Let's flip on the radio. Is there any reason why I shouldn't flip it on? Okay, we're still operating without the magic eye at this point. Okay, radio on. Volume's over here now. So there's still a hum coming through on my system here. So I don't think it's really coming from the radio itself. Okay, let's put a little volume onto it. A little volume here. Come on, radio. Okay, so I may be doing something down. Well, okay, you know what? It's probably working fine. It's just, it's hooked up to the signal generator, but not tuned to it. So we can take a quick look at the position of the capacitor plates here. You can see they're, I don't know, not quite halfway. Well, let's tune around. Not hearing anything. Something not good here. What's different about this from the last time I did this? Here we go. I gotta turn this control a lot to tune this radio. Well, we're off to a big bad start here. What is the problem? Wrong band. That's probably the problem. Okay, volume down. That's right. Now we'll go. Okay, so this is the AM band here. Oh my gosh, come on. Okay, so maybe no antenna signal. Maybe no antenna signal here. So where were those capacitors again? They are about halfway. Okay, so I'm just going to vary the frequency on the signal generator. There he is. There he is. Now that's a what I could call a moderately low signal. Where's the volume on the radio? That's full. But again, because I'm using other audio systems and varying the volume, it's hard to say what's really the volume of this radio. Too bad about that noise. Let me turn this down and turn this up. It's a little bit better. Now, and remember, the tone you're hearing is coming through directly onto this video. It's not going through the microphones at all. We're not seeing anything here, but I got this up way up. Let's go down here. Hope I don't have too much trouble with this guy. Well, is that really the volume there? Wow, that's a pretty strange behavior there. What's that popping up and down thing there? Maybe. I don't know. Okay, let's give it a little more oomph over here. You know, I'm going to add another meter in. I'm going to add an AVC meter into this mix so we can watch the AVC side of it. I think essentially everything is working and ready to go. Now the instructions say, let's do the first step here. Selector plates in flush. Oh, that's to do the IF. Broadcast. RF trimmers. Oscillator set at 1500, and the set tuned to that frequency. Well, we'll get it. We'll get close. We'll get close here. Oh, what am I hearing? 1500. And now what I can never remember is plates closed or plates open to get the let's find that guy. Okay, I'm just gonna put the level up quite high here, make sure we don't miss it. Okay, that's one extreme. Okay, that must be the wrong end of the dial. This must be the right end up here. Oh, there he is. Okay, watching this meter. Whoa, whoa, careful, man. Wild mouse clicks going on there. We'll tune it right in. Very nice fine tuning on this radio. Okay, now first I'm going to wiggle the band switch and see if this thing doesn't jump all over the place. Nope, came right back to this spot. Okay, that's a little reassuring. I think all that mechanical crunchy sound is nothing more than the spring-loaded stopper up here in the front. It's all mechanical. It's not the switch contact grinding or anything like that, which I certainly was worried about at the start. So, what do we do now? RF trimmers. With service oscillator at 1500 and set tuned to that frequency, adjust trimmers C5 and C2. Okay, now we're going to look at this very helpful diagram. I'm pretty sure last time I convinced myself this was the AM, but according to this diagram, this is the AM. Yep. So I know this is the oscillator coils here, and I know by affecting the coils you just make the radio tune back and forth a little bit. But these ones will peak the signal up if they're out of adjustment. So first one, broadcast antenna, and then broadcast RF. Antenna, RF, local oscillator. Okay, grab a screwdriver here. I will do a little sensitivity. I should be able to use a rigid metal screwdriver on all these without affecting it. So just keeping an eye on this as I bring the screwdriver in and out. Oh, jabbing the coil there. This might affect it. Yeah, this will affect it. Good. So no effect. We'll start with this one, and the objective is to raise this up. Down. Sound of a gun. Okay, we're going to back down the signal strength. I want the signal strength fairly low here to ensure that the AVC isn't working too hard. Just one moment here. Okay, a little distraction there. So we were just getting a huge boost on this radio. Wow. And what I just realized, oh boy. Okay. So I left the volume up a little bit. So you've been listening to the tone. I haven't been because I haven't had my headphones on, but that's okay. Wasn't blasting? No. So we'll try the next coil here. Amazing, eh? So this is a significant boosting here. This meter's in decibels. That's why the scale is not linear. That's also why it doesn't end at 0, it ends at 1. It never ever reaches 0. So decibels are a ratio. Anyway, I won't get into that part of it. Great. So we got quite a boost here. Let me turn down the signal again. So the signal's gone way down. Now let me tune the radio slightly and just make sure that this doesn't go up at all. That's one way. Oh, I don't know what it did there. It kind of jumped around. Oh, 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 going up. Okay, so what's happening is, what is happening? Went back down. A little bit of play, a little bit of backlash in this. I want to get it right up at the top there. Okay, so now I think the radio is tuned precisely to whatever frequency is coming out of here, 1490. This guy's jumping around. Wait a minute, my signal generator never jumps around. The output level is low. Maybe that's what's happened here. Yeah, I got the level so low, it was starting to have trouble reacting on my meter. So we're actually at 1503, which is fine. Oh, I better double check this, just in case I just knocked the signal generator off a bit, which I probably didn't. So I'm getting a little too precise here in what I'm doing for this stage of things, but why not? Okay, tuned in. Let's try the peaking up again. Shouldn't be much left here, if anything. Start with this one. A little bit, and this one. So this affects the radio's sensitivity. Yeah, this one's on now. There we are. So this boosts the sensitivity of the radio. It doesn't require as strong a signal on the antenna to produce sound out the speaker. The whole game here, though, is signal to noise, right? Signal to noise. That's really the name of the game. So, you know, just raising the whole thing up doesn't help much in the speaker. If you're trying to separate the signal from the noise, that's kind of what we're trying to do here. What else? What else? There's nothing else to tune on this band. Then let's go ahead and, you know what we're going to do at this point? We're going to stop doing the tune-up. We're going to listen to this radio carefully with a decent antenna on it, and just get a feel for what this thing really sounds like. I think that's a good idea. So I'm going to stop, fetch such an antenna, and we'll listen to it. That'll be the end of this video, I think. Okay, so I've connected the radio to this loop antenna, which is somewhat of a homebrew loop antenna, you can see there. Loop antennas are very low impedance as opposed to wire antennas, which are a few hundred ohms. So very low impedance snuffs out the noise that might be picked up by that loop. Meanwhile, the loop itself resonates strongly at its tuned frequency and generates a strong, clear signal for the radio. Let's see if we can get this to work. So that's the radio you're hearing now. Check the volume here. Wow, that's full volume. Woo. It's not such a good sign, but we are listening to it in a weird way. Yeah, so that's fine. I think that's fine for now. Let me just cut this back a wee bit. Now, let's tune the radio. So I don't know that the antenna is tuned properly. We'll tune the radio here. Give you something exciting to look at while I do it. Oh, there we are.
Immediately after the events of the finale 6 years ago, Paul telling us what we can expect.
Kind of see what truly he went through while being captured by those psychopaths, and see where these scars came from. It was revisiting an old friend that I cared deeply about.
And El Camino was written and directed by the creator of Breaking Bad, Vince Gilligan. Coming up in 60 seconds, we've got shares in Apple hitting an all-time high. We've got Stuart McGinn standing by in just 60 seconds.
Pacific News Time, 11:25.
Here's to Toronto, to the early risers, to the commuters, to the go-getters. Here's to the innovators, the trendsetters, and the people that believe. Here's to downtown, midtown, and uptown. Here's to those that work hard every day.
That would be me.
Here's to the many that never accept second best. Mankus.
In the ancient days, a symposium was
What were they advertising there?
boasting and revelry. Today, the tradition continues with friends and family at Symposium Cafe. Take time and make moments at Symposium Cafe.
The survey didn't list the bottom 5. If you're one of those people that, maybe you're dating, what profession seems to have the enjoyable extracurricular lives? If you are not active, what do you do for a living? 416-870-6400, star 640 on your cell phone. I'm just curious because this survey didn't release the bottom 5, but they did say journalists got an honorable mention for having the least sex. I myself, for the record, have never called myself a journalist, nor will I. And I don't know who's on the bottom here. I'm not using that as a literal, in a literal sense, but at the bottom of the list. But farmers having the most and the best sex once a day at least.
What?
416-870-6400, star 640
radio
on your
repair
cell phone.
guys.
Are you frightened to admit that it's not happening? What profession has the least amount, would you say? Chris, you got an idea?
Ooh, I don't know. I'm gonna think a dentist.
A dentist?
I'm thinking dentist because they're dealing with
drilling at work.
Yeah.
So, a dentist. I don't know. Dentists have a fair amount of time that they set their own hours, wouldn't they?
That's true.
What about you?
Maybe an accountant.
An accountant?
Kind of boring. Let me do the numbers.
Oh wow, okay, that was pretty entertaining. I got a kick out of that. So good. What did we find out here? We found out we were able to get a stronger signal by aligning these two coils. That suggests they were not aligned before. It may not be true. I changed some components around here. Personally, I don't think it should affect any of this, but maybe it has. But if it hasn't, then the fact that these are untuned or were tuned off indicates that there's a good potential for all of them to require some tuning. Just to keep in mind, these ones affect the dial position. They don't change the strength or anything. They just affect the dial reading, if you like, the oscillator ones. These ones affect the of the radio. Now we tuned that guy up at 1500. Not a lot of stations up at 1500. That's what the instructions say. I could retune it. I could tune these coils again down around where there's a lot of stations, like the one we're listening to. The one we're listening to is 640. Hey, let's do that. let's just listen to it, and I'll just play around.
If I can be so blunt.
Well, it's true.
You don't have a lot of time.
There's a lot of hours.
You
You're
gotta
not
get
supposed
the...
to do this, but I like
But, you know,
playing around.
I've heard about truck drivers.
Have you?
That, you know, truck stops might be a place where a couple of lonely men might meet on a lonesome highway and...
Might meet a lonely... You
same-
know what?
same
We gotta
thing.
bail from this. I'm sorry. We've got to bail from this. And we're reaching an all-new low on the program. All right, it's 11:28. We'll get to some serious headlines. The Skinny's coming up next. It's Global News Radio 640 Toronto.
When I opened my bakery, I was over the moon. But the
Didn't make
constant
much difference, I
paperwork
don't
brought
think,
me
so
back down
made
to
a difference
earth.
at the higher end, and that's why
things
you're
got
adjusting them
easier
at the
when I
higher
opened
end.
the RBC Digital
So,
Choice Business Account
now,
Package
sound
with
quality.
unlimited features like electronic debit and credit transactions, Moneris, and mobile check deposits. Now I spend less time sifting through business transactions and more time sifting flour for my hip.
So I would say the sound is fine. It's missing some of the top end. There isn't quite as much treble as I think is really available. That could be due to the IF is not tuned properly. After reading these instructions here, I realized that I may have tuned it and untuned it, and I did kind of a quick job on it. And I fiddled with it yesterday too, so I think it probably, when things are ready for the final run, it will go through the IF tune-up once again. So as for the shortwave, I'm going to leave all that aside right now because it's just getting late in the day here, and so it's maybe the last nice day here this year. So I'm going to go out and avail myself of the fine weather and try to find my cats that are wandering around out there. So thanks a lot for watching, and next video we'll finish the preliminary front-end tuning of the shortwave side of things, and then what? I don't know. Got to think about it.